Hello guys, welcome to the programming screencast of Tic Tac Toe. We had some discussions about the game which we played in our childhood, namely the Tic Tac Toe. It has a 3x3 board, that is nothing but a board consisting of 3 rows and 3 columns, that is the 9 cells. So according to us it is 3 rows, that is row 1, row 2, row 3, column 1, column 2, column 3. That is how we count, but computers count in a different way. Let me show you. See, this is how the indexing is done in a computer for a board sort of structure. This is nothing but a matrix basically. This is a matrix for a computer, that is a 2D array, that is 2 dimensions, because there are 2 dimensions, namely the rows and the columns. So it's a 2D array. This is how the computers represent the board as, that is how they interpret the board as. See, the counting starts from 0, 0, 1, 2. That is how it counts. We count as 1, 2, 3. So please note that if we say second row, second column, then it is first row, first column for the computer. So that is whatever is our count, you subtract 1 from it, then you will get the count as per the computer's perspective. This is how we have to take care of the perspectives of humans and computers. First, I would like to tell you this regarding the indexing part. Okay, now let's get started with the game. Basically, let me just give you a brief overview here. Let me give you. See, this is a 3x3 board, that is a board containing 3 rows and 3 columns. So players, there are 2 players in this game. Each player is given a symbol. One is given a symbol X, one is given a symbol O. They have to, initially the board is fully empty. They have to place their symbol in one of these vacant positions in the board. This is how the game goes. Suppose the player 1 places here. Next time player 2 cannot occupy the same position. He has to occupy the vacant position. Something like that the game goes. And if you would see, the player who occupies consecutive 3 cells along any of the rows or any of these columns or along this diagonal or this diagonal is considered to be the winner. That is, the player who is able to first occupy 3 consecutive cells in this manner is the winner. In case if no one is able to do, then it is a draw. So here, as I had discussed in the lecture, the game is not just about your moves, it is about your ability to predict how your opponent will play. So every player will play in keeping in mind that he has to maximize his chances of winning and minimize the chances of the opponent's winning. For example, let me just give you an overview. It is better if you could have a pen and paper, draw a board, because for indexing purposes I had taken this particular image. But a plain board would be beneficial, but no problem. You please take a paper and draw this kind of a grid and follow my instructions, and based on that you can understand. So if this is basically an empty board initially. So the first player comes, places his symbol here. Why this place? Because along this diagonal or rows or columns, anyway, in at least one of these ways he has to occupy 3 consecutive positions. Only then he can win. To maximize his chances of winning, this particular position 1,1 for the computer and second row second column for humans, this particular position is in intersection of many of the winning possibilities. Along this diagonal, row this column, along 4 of the winning possibilities. There are 3 columns, 3 rows, 2 diagonals. Among 8 winning possibilities, on 4 of the winning possibilities, this particular cell is present. So a smart player would start playing at this position to maximize his chances of winning. So this will be the first player's move. So the second player, when he gets the move in the next turn, he would want to maximize his chances of winning, also to block him from winning. That is, to minimize his chance. That is, he wants to block him from winning. So here if you have a X, so he would like to block one of the 4 winning possibilities for him. So maybe he can place his coin somewhere here, so that this row possibility has been blocked. So now, given that this row possibility has been blocked, in the next turn, if the player X places his coin here, it is a waste. So he would place his coin somewhere here. So now, if you have seen till now, here you have X, here you have O, here you have X. So if somehow this is now O's turn, if somehow in the next turn X could be placed here, X would be the winner. O thinks in that way, that if I miss this particular location, next time X will place his coin here and he would be the winner. So he would place his coin O here to block his winning opportunity. I guess now you have understood what the strategy players would be using. They would want to maximize their chance of winning, as well as they would like to minimize the chance of the opponent's winning. If both the players are smart, just try dry running any sequence of runs. If you try dry running, just think that both the players are equally smart, it would be a draw. In case if at some point of time the player loses the foresightedness, he doesn't think of his opponent in some point of time. Suppose assume that in this particular instance, O doesn't place his coin here, he places somewhere here. The next turn when it is for X, X would place his coin here. Then thinking of blocking O, it is beneficial for him to place his coin and win. So your aim will be both. More priority to your winning, at the same time not a minimal priority to defeating your opponent. You have to minimize his chance of winning, you have to block him as much as possible, as well as increase your chances of occupying 3 consecutive cells so that you can win. So this is how the game goes. As I had recommended, if you had taken a blank sheet of paper and dry run how the game would go, just play the game without using a computer, just try, you would understand how the game is played, what kind of smartness is required from the player for the game, and so on. So this is how the game goes. Let us now start coding now. Okay. So as I had said, it is a 2D array. The board is a 2D array for a computer. So that arrays has been defined in a package called NumPy. Let me import it. Import NumPy. Okay, I had imported. So let me call it as board. That is the name easier for me. So let me call it as board. I would say NumPy dot array of, we need an array of 3 rows and 3 columns. We need to give it as a list, and within the list each row has to be a separate list. So you have blanks initially. So for blanks I am representing it as hyphens, that it is a blank cell. That is what I mean by hyphens here. So I have 3 columns in each row. So 3 hyphens I would be giving. All these 3 are blanks. I'm sorry for this. First row has been given. Now the second row. So let me give. Okay, second row is over. Now the third row. Okay, first column of the third row, second column of the third row, then third column of the third row. So all 3 rows has been defined. Okay, now for player 1 the symbol I allocate is X. As I had told, it is X. For player 2 I allocate the symbol O. So that is what I had defined here. Player 1 symbol. Player 1 symbol, for symbol I am using S. Player 1 symbol is X. Player 2 symbol is O. So now let me start the game. Let me say play. As we would have seen till now, just saying play won't serve the purpose, because it is something we are defining. See, you got a warning symbol. It is an undefined name. So we have to give the proper definition as to what has to be done when you say play. So let me define it. Define play. Okay, give colon here. So here starts the function definition. So every particular turn, the turn has to be alternated. The first turn, if it is given for X, the second turn must be given for O. So how many turns would be given totally? It is a 3x3 grid, that is there are 9 cells, so there will be 9 turns. So let me say for, I'll use a for loop because I need to repeat it 9 times. Turn I use intuitive names so that it is easier to understand. Turn in the range. You would have seen this syntax till now. This is how you use for loop for a predefined number of times. I want it 9 times, so let me say 9. For turn till the range of 9, what you do is, it starts from 0 up till 8 it will count. So 0, 2, 4, 6, all these turns should correspond to player X. Then 1, 3, 5, 7, that is even turns is for player X, odd turns is for player O. So how do we capture this? Using the modulo operator. Let's do that. So I'll use if turn modulo 2 is equal to 0. That is, if it is an even turn, you should say it is the turn of X. Let me print X turn. So this is the turn of X. Okay, so you should allow him to place his symbol on the board. So let me call place player 1 symbol, and then after he places his symbol, initial 2 moves, if you would have observed, the winning possibility is from the 5th move only, but still this single loop will be running for all the turns. So let us include this check here, but it will not be used in the initial stages, but in the subsequent stages it would be needed. That is, as soon as there is a winning move, that is, if there is some vacant slots till now, that is all 9 slots have not been occupied, but still there was a winning move, then the game has to stop. So for that, let me say you have to, if 1, let me use terminology like this, if someone, this player 1 symbol, this person has 1, then break. That is, you should quit the game. This is nothing but we are quitting the game. Else. So this is for player X we had done. Else. That is, the turn is odd turn. So all these things we would copy. We would do this for player 2 whose symbol is O. So I had used O, player 2 symbol, and if player 2 symbol, this particular thing has 1, we have to check. That is, why do we check this? As you would have seen in this dry run, during the 5th turn, there is a possibility that one player can win. That is, from 5th turn, anyone can win. There are good amount of possibilities that there can be a winning move. So if that particular move, he has placed it in some position, and if that placement is a winning placement, then you should quit the game. That is why we are using this. So far so good. These are intuitive names, so I guess you could understand it. That is, you have to repeat these things 9 times. That is because of the 9 cells present in the board. If for every even number turn, this is for X, and odd number is for O. Allow the player to place his symbol into that vacant slot, into a vacant slot in the board. Check if that is a winning placement. You quit the game. This is what we have done till now. Okay, as you could see here, see, these are undefined names, place and 1. So let me define that here now. Okay, define place. So we have used P1S, P2S. Let me say symbol. It is a common terminology. Player 1 symbol, player 2 symbol, whatever be that, it is a symbol. So I had said that. Okay. So first, what should I do? Print the board. So since it is a matrix, that is, I have to display it in the rows and columns format. So for that, we have a predefined functionality to convert it into, this is in the list format, we need to convert it into rows and columns format. For this, we have a predefined functionality. Let us use it. NumPy dot matrix. There is a functionality here, NumPy dot matrix. Within that, you have to pass the name of the variable. Here it is board. That is, it will take the value of the board in list format, convert it into the row and column format and print it. That is the purpose of this functionality. Okay, we'll print the board. Then we have to say, we have to get the input for in which particular row. That is, how does it, what does this signify is, you are saying that you should allow him to place his coin. Where would he place? In some particular cell that is identified by the row number and the column number. So row, get the input from the user. Row is an integer, so let me typecast it initially. It's easier now. Okay, row, I should get an input. This is actually a dependency on a Mac system, that's it. In Linux systems, as much as I have used, this particular typecasting thingy is not needed. These are all some trivial things, depends on your operating system. In case you are using some other system and there is some other requirement, you can always Google it and get back the correct method as per your system. This I am doing it with respect to the Mac system. Okay, so I had typecasted, I am taking the input. So I should say enter your row position, enter row. What are the values for rows that is allowed? 1 or 2 or 3. These are the allowed rows. Okay. That is as per the human's perspective. I showed you a counting that starts from 0. Why is it that we are giving 1, 2, 3 here? Because this is as per the human's perspective. You are familiar with computers, so you can understand this indexing mechanism. But whereas if you would ask, and this must be designed so that anyone can play the game. So for humans perspective, the counting starts from 1. That's why we are giving like this. Then we'll adjust it in the upcoming steps. So you get the input and copy, paste. Okay, column. So I should say enter column. Column 1 or 2 or 3. So I had said that this is the value you have to input it. But what if the person has inputted a row and column that is already occupied? Or what if by some typo mistake or something, he has inputted a value that is out of range of the board? We have to handle it. All this we are doing it to ensure that your program is robust and fault tolerant. That is, whatever be the fault that may be occurring due to the user's input, it must be handled. Your program must be able to handle it. We should not say that it is your mistake. We should be able to handle it as much as possible. That is one of the principle in software engineering, that you have to make your systems friendly and fault tolerant. That is, if the users commit some mistakes, even your software must be able to handle it. You must be able to display him some polite, nice message that this is the reason why this cannot be accepted. Please try again with the valid thing. Something like that. That is a courtesy. That is the practice followed generally. So let us do that here. So let me check if it is a valid input, I have to say okay, you can place it. So how would I do that? In case if it is an invalid input, I should repeat the process. So I need to use while loop here. So let me use it. While 1, because it has to run infinitely till you get the correct input. So correct input, if it is a correct input, I have to break. So what is the correct input? Row, the value of row is greater than 0. 1 or 2 or 3, all are greater than 0, right? And the value of row is less than 4. 1, 2, 3, all are less than 4. And even column must be same like this. Column should be greater than 0 and column is less than 4, and that must be a vacant column. For vacant, what are we using it? We are using a hyphen. So I am going to check that one. Board of, should we use row column or row minus 1 column minus 1? It is row minus 1 and column minus 1. Why do we use it? As I had shown you the indexing earlier, computer starts counting from 0, whereas humans start counting from 1. This we had taken the input in a human friendly manner, but we have to convert it into a computer friendly manner. That is why we are deducting 1, as I had shown you that time. second row and second column of humans is nothing but 1, 1 for computer. So you have to subtract 1 from both the indices, row as well as column. This is how the computer works. So if the human says second row first column, it is nothing but 2 minus 1, first row and 1 minus 1 0, first row 0th column for the computer. So this is how the computer will interpret. Because why is this different? Because humans start counting from 1, computer starts counting from 0. That is the reason. So if this particular thing is blank, blank is given by hyphen. If all these conditions are satisfied, that is row and column are within this range 1 or 2 or 3. So it is greater than 0 and less than 4 is nothing but 1, 2 or 3, and column is also the same. And if that is a vacant position, then it is a valid input. You can break here. That is, you can let him place, breaken from the loop. So corresponding to this, here you should let him place board of row minus 1 and column minus 1 is nothing but the symbol, whatever the symbol he wants to place. This is how the place functionality works. Please check once again. It is, you are displaying the board, asking them for input to enter row and column value. In case if they enter a faulty input, or if that is not a vacant position, you will repeat asking for inputs till they enter. And if you again and again ask inputs, they will get irritated. So you should say, if this particular, this is for checking that whether the input is a valid input. If it is not a valid input, you should print saying that invalid input, please enter again, some polite message. Only then they will understand that okay, they had made a mistake and that is why you are asking the input again and again. Otherwise they may think that there is some fault with the system, that's why even though I gave an input, it is asking again. That is what people will think. That is why we have to print a message in a way that they can understand easily. This is important. Please note this. This is important. So we'll ask input as long as it is not valid. Once it is valid, we break from this loop and we place that particular player symbol here. So see, place player 1 symbol in even numbered turns, player 2 symbol in odd numbered turns. So whatever is the symbol being passed here, that would be placed in that position. So this is how it happens. So place has been done. So please see to the floor till now. Maybe you can pause here for some time and then you can see it. And yeah, see, we had missed one more thing. If this player 1 has 1, you should say break. Player 2 has 1, you should say break. If no one has 1 at the end of 9 turns, that is all the cells has been occupied and still no one has 1, you should see. You should tell that. That has to be included. So let us include it. If, you should say if that is not 1, if that person has not 1, player 1 has not 1. See, not is an operator that is predefined. That is, 1 will say if the person has 1 or not. That is, it is true or false. If it says true, and if you apply not, it would become false. So it will invert the output of this particular thing. It will invert whatever is the truthfulness sent to it. That is what not does. Okay. And not player 2 is also not 1. Not 1 of player 2 symbol. If both haven't 1, then you should print it is a draw. Okay. So why did we do that? Because draw is also possible. So that is why we had done this. This, okay, indentation is important. It has to be at this particular position only. Column 5. Because at the end of all turns only you have to check. That is, all 9 cells have been occupied and still no one has 1. That means it is a draw. So we are checking it here. Fine. Let me change the indentation here too. Okay. So this and this will be the same level. Yeah. 9 and column 9. Fine. Okay. Please pause till here. Understand the flow of the program, and in the next video we'll see how this functionality 1, which says whether the person has won or not, can be realized.